Okay,
We're recording.
so we are recording now. Again, this isn't 100% section 6.4, but it's chapter 6. We're still in chapter 6. That's really what we need to know. And our goal is to be able to find C if we're given an initial condition. And when we say initial condition, that's the same thing as an initial value.
Initial condition equal to initial value.
So they're going to give us an x value and a y value to work with. And that means we can find C. So just to recap, because we didn't get a full talk about fundamental theorem of calculus and we didn't really record it, so now it will be recorded. If we have the integrals from a to b of f of x dx, what did the fundamental theorem of calculus state? F of b minus f of a, but there was something special about f. Capital to mean antiderivative evaluated at b, antiderivative evaluated at a. So you found the antiderivative, and then you plug in the top bound minus the bottom bound. And really, when we were finding the antiderivative functions, it took the area minus the smaller area to give us the area between 2 points. And when we're actually applying this to situations, when we find this information, it finds two things. We could either talk about it as it being the area under the curve, from A to B, and there will be some situations where we talk about it that way. Or we can consider it to be the net change in distance. So not our position, but how much our distance has changed from start to finish. So net change from A to B. So I could have traveled further. I could have walked actually 50 feet, but maybe I started at 12 and ended at 15. So my starting position to ending position, the net change is only 3 feet, even though maybe it took me 50 feet to get to that 3 feet change, but we're just talking about net change when we're talking about fundamental theorem of calculus. So we also worked with indefinite integrals. And when we worked with indefinite integrals, what came up as we were working with them? What did we have to remember to add at the end? C, because there's actually an infinite number of solutions to this. I could have 1/2 x squared minus 5x plus 5, or 1/2 x squared minus 5x plus 10, or 1/2 x squared minus 5x plus a billion. We had an infinite number of solutions. So if we take the antiderivative, we have to use anti-power rule. So we're considering this, what was inside, the derivative. So this is y prime, and this is y. So this whole thing we consider to be, if that's the derivative, when you integrate the derivative, you get the original function. X squared minus 5x plus c. So if I want to find a unique one, that means I don't want it to have an infinite number of solutions. I want one to be my answer.
One is
So,
number.
No, one as
One.
one number for c, not,
Multiple.
yeah, not multiple values possible. So what information would I need if I want to find c? What would I need in here to get rid of all the other variables I don't want and just find c?
A point on the graph.
Okay, any point on the graph. If I had an x value and I had a y value, I could plug those pieces of information in and find c. So So that's what we need to do this. We need an x value and a y value. We need that information in order to find C. And then I could get a unique answer. So I could present this a couple of different ways, but we still just take the antiderivative normally. We're going to take the antiderivative normally, and then whatever x value and y value we have, we're going to plug them in and solve for C. So it's not a whole lot different than what we've seen already. Just takes it one step further. Everyone have this written down before I go to the next page. Okay. So I could present this a couple of different ways. Saying the integral of 2x squared minus 5x dx if the antiderivative evaluated at 2 is 3 is one way I could present this. But I could also start it out without an integral symbol at all. I could tell you, so just a second way to present this, I could say dy dx is 2x cubed minus 5x, and hold on, I want to make sure I present this the same way as the homework. Y of 2 is 3. So that's saying the same thing, but it's presented a little bit differently. And it is the same thing. The instructions will say to solve the initial value problem.
So dy dx is antiderivative.
So dy dx is the derivative, just like we know this stuff is the derivative. And if we integrate the derivative, we get the function. So if they present it this way, we just have to put the integral on ourselves. I was originally going to give you an assignment presented this first way, but I decided to change what assignment I was using, and they're presenting it the second way. So I had the notes written for the first assignment that I was doing, but it will really be presented this way. So you're going to have to realize, hey, to get from a derivative to a function, I have to integrate. So we know if I integrate this, what's the integral of a derivative? The function. So if we use dy dx, what notation would the function be? Y. And then the other side, we just integrate normally. So anti-power rule. So we would have plus 1 x to the 4th, divide by 4, 2/4, which is 1/2 minus x squared, divide by 2 plus c. So that's stuff you've done before. You have taken the antiderivative, you've known to do plus c, and now all we want to do is find c. So, which of these values is x, which is y? 2 is x, 3 is y. They're using y of x instead of f of x. I don't know why they decided to do that, but they did. So, x is 2, y is 3. We plug those values in, we would get 3 equals 1/2 times 2 to the 4th minus 5/2 times 2 squared plus c. So now we just solve for c. Now it's just down to algebra. 2 to the 4th, 16. Yes. 16 divided by 2 is 8. Minus 2 squared is 4. I'm going to divide by 2 first. 4 divided by 2 is 2. 5 times 2 is 10. And you don't have to skip some of these algebra steps. You could write it out in more detail. So when we add everything over, c equals 5. Now that's not our final answer because they wanted the entire function. We need to just write the entire function again with c replaced by 5. So the unique function at that value is 1/2 x to the 4th minus 5/2 x squared plus 5. And I could take that same problem and give you another initial condition, and you could find a different c value. Okay, so I'm going to have you guys try one. And one of the reasons I wanted you to log in is because I'm going to have everyone enter their answer in after you've tried it out. So your final answer should be y equals whatever plus a number instead of c. So that's what you're going to enter in to the Inspire. I'm going to send out a quick poll. This time it came out as 0.
I just have this like 5, and I'm like, well, they're doing something weird over there.
So when we take the antiderivative, we should get positive 3 cotangent x, because the antiderivative is normally negative, but a negative times a negative is a positive plus c. We plug in our values, we get 3 equals 3 cotangent of pi over 4 plus c, and then cotangent of pi over 4 is 1?
Yes.
Okay. So then, if this all is 1, minus 3 from both sides, we get c is 0. So the unique solution is y equals 3 cotangent x. We could write plus 0, but why? Why do it?
Is that a rhetorical question?
Yes.
Okay.
So I could do this in multiple steps. What if I gave you f double prime, and I had 2 initial conditions? I gave you what we knew about f prime and what we knew about f.
Oh, that sounds
So let's say f double prime of x is x cubed minus 2x plus 1. And we know f prime of 0 is, nope, sorry, f prime of 1 is 0. I was looking at the wrong line. And f of 1 is 4. So I heard someone at this table say, well, doesn't that just basically mean you've got to do it twice?
That was me.
And you're right.
Yay.
You basically just have to do it 2 times. If we integrate this, if we integrate f double prime of x, and we integrate this other side, what's the integral of f double prime? What's f double prime's antiderivative? F prime. Stephanie is correct. The integral of f double prime is f prime of x. And then the other side we just do anti-power rule. And we will learn some more complicated ways of integrating, but we're trying to get a general sense of what the integral is, what it means, all the things we can do with it. And so next section we'll have some of the more complicated ways of actually integrating. So we take our antiderivative, 1/4 x to the 4th minus x squared plus x plus c. So which values will I be using when we're doing this level? 0 and 1. F prime is values. Okay, so which one of these is x, which one's y?
1 is x, 0 is 1.
1 is x, 0 is y. So we replace this entire thing with 0. We replace all the x's with 1. So these would cancel each other out, negative 1 squared and 1. Because 1 squared is 1, negative 1 plus 1 is 0. So what will C be? Negative 1/4. So now we know f prime of x is 1/4 x to the 4th minus x squared plus x minus 1/4. And then how would I get from f prime to f? Antiderivative of that. So we integrate again. So we get f of x. This time, when we anti-differentiate again, our fraction is going to get kind of small. Feels big since the number will be big, but it's really getting smaller. If we have x to the 5th, and I do 1/4 divided by 5, what is 1/4 divided by 5 going to give me? 1/20. 1/20. It's the same thing as multiplying 1/4 times 1/5. Minus 1/3 x to the 3rd plus 1/2 x squared minus 1/4 x plus c. So yeah, this one does have a lot of fractions. And we did f of 1 is 4, right? So everywhere I see x, I plug in 1. F of x I replace with 4. So basically, if we plug in 1, we just are left with all the fractions. I'm not even going to bother writing in the 1 because 1/4 times 1 is 1/4. 1/2 times 1 is 1/2. So we do have a lot of fraction work here. So if I were not doing this with my calculator, just to practice, okay, because sometimes they do have you do some pretty intense fraction work by hand. What would our common denominator be?
20.
No.
Almost. 3.
3.
I know. That's what I thought at first. I was like, 20. Okay, we can do this. So 3 doesn't divide into 20.
Well, yeah, but 20 doesn't divide into 3.
Yeah, so people were saying 20, but then they're saying 3 makes that not work. 60.
Confusing me.
So we have 4/1 times 60 would be 240 over 60.
Or over 60.
I'm going to just subtract these over so we can combine it all together. Minus, need to multiply by 3 over 60 plus 20 over 60 minus 30 over 60 plus 15. 15 over 60.
But it's minus.
Except that I am moving it over to the other side. So I changed the signs of everything except the first one. And now we combine. I would actually maybe do this stuff first. Like 20 minus 30 is negative 10. Plus 5. Or sorry. Plus 15 is 5. Minus 3 is positive 2. So we have 242 over 60.
Equals C.
Is that reduced though?
Goodbye, where do you want to go? No.
Good luck.
Swim like a fish.
Or a dolphin?
Oh.
Like Aquaman.
121 over 30.
We could reduce this 121 over 30. And then, again, this is not my final answer. We still have to write f of x equals. I know it feels like we should be done because we have what c equals. Hooray.
Then you plug it into the very.
Yeah, we just have to rewrite the whole thing basically and just. So 1/20th x to the 5th minus. Was 1/4 x to the 4th?
1/3.
1/3. X to the 3rd.
Plus 1/2 x squared
Thank you.
minus 1/4 x.
Plus
121 over 3. Bam!
Yep. So it does take.
Language.
Bam.
I said bam!
The B.
Bam! Sorry.
So let's have you guys try one.
That's a good one. More than
I know it does take a lot of work because we had such a long polynomial.
No.
Sorry, I thought you were done.
Last.
Do you need me to go back?
No, I'm just copying off Josh.
Okay.
Wow. Ms. Barton teaching us to copy off others. Good.
Hey, that's what I learned from the assembly. You get a frisbee for it.
It was like the first one of the year.
I know. You never forget when your people teach you to cheat, man.
2.
2, square root of 4. So we have 1 equals negative 2 over 2. Or negative 1. Then we add 1 to both sides. So your first C is 2.
Oh,
I got
well, look at that.
Okay, so we got the first C was 2. Then we go and write out our new, oh, this should have been y prime equals, I apologize, not y equals. Y prime equals negative 2x to the negative 1/2 plus 2. Then we integrate again to get to y. We integrate again. We get y equals, we add 1 and get positive 1/2. What do we get if we do negative 2 divided by 1/2? I think this is where a lot of people may have gone wrong. What did you say? Negative 4. Negative 2 divided by 1/2 is negative 2 times 2 over 1.
Oh.
Got to be careful with your fractions. If you need to, write them out. Write it out old school so you don't make little mistakes like that. So we get negative 4 plus 2x plus c. So does everyone else see where they're making their mistakes?
Yeah.
And then we plug in our values. This time we had 4 equals negative 4 times 4 to the positive 1/2 plus 2 times 4 plus c. Negative 4 times 2 plus 2 times 4. And if we have a negative 4 times 2 and a positive 2 times 4, they cancel each other out. We get negative 8 plus 8. So we get 4 is C. Then we do still have to write our final answer. Y equals negative 4 x to the 1/2 plus 2x plus 4.
Can you plug that C back into the f of x, right?
Mm-hmm. So the last thing we could do with this is word problems. So they're going to give us particle. We do a lot of particle problems. You see those on the AP test quite a bit. Moves along the x-axis. velocity v of t equals negative 1/2 t to the 1/3 plus 4/5 t to the negative 1/4. I just want to practice our fractions, so that's why I made one with a lot of fractions.
I noticed.
Meters per second. Find the position. And remember, usually for position we either do x of t or s of t. I have no idea why they choose one over the other. This book is using s of t, assuming, and this time we really are probably going to get some weird decimal for c, s of 2 equals 1. So I know you guys hate word problems, but oftentimes it's just a fancy way to say, do what we've been doing already. So if we do what we've been doing already, what should we do? Take the antiderivative of v of t. And if we take the antiderivative of v of t, we get position. So if I anti-differentiate, dt this time, then this will give me position plus c. And once I have that, I still just plug in my initial conditions. So it's not any different from what we've already been doing. It's just a fancier way to ask us to do it. So I'm going to have you guys take the antiderivative, and then we're going to just plug the antiderivative into our quick pull. I want to make sure you guys can do these fractions. So now we just plug in the information and find c. This one, again, will probably be a little weird since I made it up to have so many fractions. So s of 2 is 1. And at this point, we're going to have to use our calculator. There is no cube root of 2. There is no fourth root of 2.
That we know how to solve.
Yes, that we know how to solve. I mean, there is one, but it's a weird decimal.
So did they program that into the calculator?
They did. Or they programmed a way for the calculator to find it. One of the two.
They being some super smart people.
Yep. So I need you guys to plug this in since I don't have a calculator up here.
Oh. The legs are broken. Guess that was fun.
So we're getting one answer, negative point.
188,393.
Is that your final answer, or is that just the right side?
I got for
That's just for I saw.
So there's one.
I got for C 0.154028. That's what I got.
Okay, so we're getting 3 like that. So you could do this 2 ways. You could tell your calculator to solve. You can use your calculator, and your calculator could just solve the whole equation for you. Or you could plug in 1 plus this minus this. There we go. If I want, there we go.
Didn't want it simplified.
So we could do 1 plus 3 divided by 8 times, it was 2. raised to the
4/3.
4/3. Minus 15 16ths or 16
I think I
15ths?
got it wrong.
16/15.
Times 2.
Are you in the-
That's all in the
Ah,
same
I
exponent.
swear I pressed the right arrow. Why am I doing that? I just did this. Stop it!
Turn blue.
I don't know why.
You made it sick.
There we go. Minus.
I got the .1 thing too.
Okay.
Okay, this is what the calculator did.
And then what was the second
Okay, so
exponent?
yeah, I forgot to put in 3.
Okay.
Okay.
Wait, we got different answers.
Okay.
Ah.
That's probably my fault. See, that's
That
what
was,
mine
I
did.
did
point
too.
one-
Oh.
1028.
Okay, that is
I
correct.
solved it, you didn't.
There you go.
So 0.151 is all we need because we don't need to plug it back in. If we were doing an equation, they may ask you to estimate something using this. So maybe we would want all 5, but this one, our final answer is just y equals or s of t equals or whatever we're working with.
Mine looked
If you
fast.
press Control Enter, then it gives you the decimal and you don't have to go to the menu.
Yes,
You've been doing that the whole time?
I didn't know.
You didn't know that?
Nope.
Oh.
control does a lot of things. Okay,
It's
so
like, is it
on
one
your
control?
homework, I copied this from a different
Oh, yeah,
book
you can-
because, again, I do not like it all the way your book is writing these
Don't twist my
out.
book. Yeah, but it's good.
What did you do? Is there 2 different pages or what?
One for each of you. Originally, I gave you my master copy that did not have the backside.
Oh.
So the problems you are going to do,
Whoa! It's like copied out of a book.
yeah, it's
You
a
said
different
it
book
is.
than our book, though. Problems
But you
47
copied
through
it.
52, 55.
It's
Or what we
broken.
These are what we
Gonna drive
can't
me
do.
insane.
No, these are what I would like you to do. You could do quite a few problems on this page,
Oh,
but
this is what we're doing.
there's a lot of problems on this page, so if you would like to do 54 problems, you
I
can.
feel like actually.
But I was hoping you'd only want to do like 12, 15.
If I do all 54 problems,